All right, so good evening. It's Wednesday, the day after our lab yesterday. And what I'm going to do is go through a quick rundown of how to explore correlation analysis um, in our lab, right? So we're going to look at some real environmental data. We're going to look at sea surface temperatures and precipitation data sets, look at the relationship between those two in different areas, and produce some maps and plots and interpret them, discuss them, okay? And we're going to do that using two platforms, both which you've used already. One is the NASA Giovanni data portal. The second one is the NOAA Physical Sciences Division plotting and mapping tool, I think is what it's called. All right, so let's go ahead and get started. I'm going to share my screen. Let's do this. Let's figure out how we do this. Come on, share the screen. Screen one, let's do that. All right, so here we are. There I am in the corner down there. Okay, so first, let's open up NASA Giovanni. Opening up a tab. I'm just going to type in NASA Giovanni. There it is. Boom. Click on that. And this should look familiar. It's the entry, the gateway to the portal. Now, don't forget to log in. You should have already registered. If you log in, that'll allow you full access to all the data. I just put in my username, my very secret, top secret password. I log in. That's all it is. Now I can have access, unrestricted access to all of the NASA Giovanni data sets. Okay, pay attention. Let's get started. We're not writing this down. We're going live. So what did I say we want to do? We want to look at rainfall and sea surface temperatures. Let's find those, okay? So measurements. Is that what it is? Yeah, let's just click on measurements. We'll go down and look for sea surface temperature. Look at these fascinating things you can plot, analyze in NASA Giovanni. Runoff. Look at that. Sea salt. Yummy. All right. Sea surface temperature. Boom. We want that. Okay. And we've got all these different choices. Let's narrow this down. We want monthly. So I can scroll down to the temporal resolution, basically time. I can get monthly, click there. Now we have only 8 available options of sea surface temperature and a monthly scale from NASA Giovanni, and they're right here. All right. Now, for this purpose, we're going to select this one. Okay. So we're going to click the third one. What is the third one? Well, it says sea surface temperature at 11 microns for the day. It's part of the MODIS satellite data set. Level 3 doesn't mean anything to you, but that's what it is right now. Units, degrees Celsius, monthly, horizontal resolution 9 kilometers, beginning and end dates. All right, so click that. That's going to be one of them. Beautiful. Now we also want rainfall, so let's find rainfall. And we know with the rainfall, we're going to use the GPM, Global Precipitation Mission. I think that's what it's called. So we're going to just go down to platform and instrument. Sorry. You got to click precipitation first. Boom. Now I go down to platform and instrument. And look, we have GPM. And there are only 2 options. Why are there only 2? Because we want the monthly. So GPM, we have 2 monthly options. Notice our first sea surface temperature is still selected. That's critical, right? That's great. Now the second one, do we want satellite gauge rainfall estimates or do we want random error? We do not want random error, so we're going to click on the satellite gauge estimates, right? And that's for just for the fun of it, instead of a rain rate, instead of millimeters per hour, let's go millimeters per month. Okay, so we're looking at monthly data. Cool. So let's do this, all right? So these are the 2 data sets we're going to compare. Now, how are we going to compare them? Well, we're gonna do a correlation. We're gonna map that. But before we do that, let's actually extract. Let's look at a time series of each of these because we want to compare the time series. We want to see what the variability of one time series looks like compared to the variability of the second time series. So deselect these. Boom. Up. I didn't. I'm sorry. I should have. Where is my sea surface temperature? I need to go back and find my sea surface. Where did that go? Boom. Oh, good. We're doing this together. This is great. Sea surface temperature, come back. Where are you? There it is right there. Sea surface temperature monthly. Let's take off rainfall. Cool. We still have our rainfall selected. And we wanted our sea surface temperature. Remember, we wanted this one. This one. Monthly daytimes. Click those back on. Okay, look. Now what happens if we do time series area averaged? Okay. Time series. Now, when's the time begin? Just for a little info, I shouldn't have deselected that one in the first part. That's what made us go back and reselect it. So keep those selected. We're going to do it area average time series. Starting when? This one starts in 2000. This one starts in 2002. So we should not go sooner than 2002. But for our purposes, time constraints, let's just start at 2010, January of 2010. Okay. And then we're going to end that in December of 2020. Come on, not July, but December of 2020, okay? Now, we're going to select a region. We're going to click this little box here, draw a bounding box on the map. There's our planet, our world, our map. It's the world we live in. We are going to, or I should say, I am going to select a region somewhere outside of the Caribbean, but for your lab, you will want to select the Caribbean, okay? So just out of curiosity, I want to pick the central, more like the equatorial, tropical Pacific. So to do that, click that little square box at the top. I'm going to drag my mouse and undrag it, drag and release. Look, we're going to look at this area average. Actually, I'm going to make it smaller. Yeah, because we're just doing a demonstration. I'm going to make it smaller. There, that should take less time. I'm just picking things right now. I'm not doing any research. I don't have a specific question I'm trying to answer. I'm just looking at a demonstration. So I'm going to pick a small area. Good. So I can X that. All the coordinates are automatically populated. Area averaged, area that's going to be averaged. What happens if we push plot data? Now we wait. Okay. Wait. And the bigger your area, the more data is being crunched and the longer you wait. That's why I went back and picked a smaller area just to make the time crunching a little shorter if we're lucky. All right. So, yep. What do we got here? It says averaging on Fox at 6 of 6. Okay, so I'm just going to sit here and wait. Cool. That is the great. We've got two time series here. Perfect. That's what I want, right? Now, first time series is rainfall. How do I know that? Look at the title. Time series, area average, merged satellite gauge precipitation estimate. Units are in millimeters per month. Look at this. I can see there's some sort of annual cycle, a peak, a minimum, a peak, a minimum, a peak, a minimum, so forth. It's a little interesting area. Peak, minimum. Now this is the some part in the equatorial Pacific. Okay. Now let's go down. What's our second one? Oh, this is sea surface temperature. Well, look at this. Look at this. Look at that huge peak in monthly rainfall around 2016. coincides with this huge peak in sea surface temperature. So I'm already starting to ask myself, how are these related? What's the relationship between these two? Let's explore that question with some correlation analysis, all right? So I'm going to copy these, add them to the lab report. I can just probably, I can right click and do save image as. I believe I can also do this, download the image. Just click that and looky here, it is already downloaded. And if I open that, I only get, oh yeah, I get the top image. I have to get the bottom image, I've got to click this too. So you have to do, for instance, here is what the top image looked like when I saved downloaded the image, and here is what the bottom one looks like. Cool. So I've got two images now, basically two time series downloaded, and I'm going to save those for the lab hand-in. So great. All right. This is important because, or I should say, these time series are important because they provide the basis for the correlation analysis. It shows the variability within the time series for both of them, right? Okay, so we've done that. Now, let's start answering some questions. What is the relationship? Is it positive? Is it negative? Or direct or indirect? And what's the strength of that relationship? Remember, these are linear relationships, right? And so let's explore that with correlation, and we'll do a scatter plot. So we're going to go back to the bottom right, back to data selection. Boom. And rather than picking the select plot, instead of the time series, all we're going to do now is do scatter, time averaged. What is the difference between interactive? No, we want area averaged. We want area average, right? So we're going to average. We're going to average that area in space, and we'll get a scatter plot for the monthly values. Okay, so that's what we're going to do. I don't know what the difference between interactive and static is. Maybe we'll explore that. Let's just push static now, and boom, it's there. I'm going to push plot data. And then now look at this. Our time series is hidden down here. We can still see all the information there. And now we're working on the scatter area. So NASA Giovanni saves all of your results here on the left. You can go back and ask yourself, oh, what was the user input there? Oh, can I download it? What the plots look like? All right. Okay, now here's where there's going to be some time consumption, because look, regridding all these different files so that they're the same size. So I just sit back, take a break, wait for those two numbers to match. We're on 60 and 132. I want 132 and 132 in this case. So about halfway there. Again, depending on your internet speed, you could be sitting here for minutes or seconds. And I'm going to say a few more seconds in my case, right? So we're already up 102 out of 132. And really close, 123. I feel it. I feel it. 2 more to go. And regridding should be done. It's still working on something. Oh, now we're subsetting files. Okay. What is subsetting on file 6 of 5? Waiting on file set 6 of 6. So it's doing all the work for us, right? That's the beauty of these data portals. It's just point and click. It does everything for you. You don't have to write all this code, bang your head on a keyboard trying to figure out what's the code for Y text labels. You don't have to worry about that. So, yeah. So if you're watching this, and before you do this, maybe have something to keep you busy while you wait. A book, if you like to doodle, write poetry. Converting units, workflow failed. What? Please send us feedback and we'll investigate. What is that all about? Okay. Converting units, workflow failed. Let's go back and look at our user input. Okay, why did the workflow fail? Back to data selection. Well, let's do this. Let's put it back to millimeters an hour the way it was, okay? Is that the problem? Oh, let's do this again. Scatter, area average, static. We're gonna try this again. I put those units back to millimeters per hour. I can't imagine that's the issue, but here we go. We wait. We wait. All right, now it's recreating all that stuff again. So this is what we're doing in video, because you're seeing in real time that, hey, it's not always perfect. And now we get to diagnose why it's not perfect. Why did it fail? I don't know. I'm just taking a guess. It was that switch in units. I don't know. Shouldn't be. We'll find out. So we did this on Tuesday and it worked perfectly. Or I did this and it worked perfectly. Let's see what's going on. So we got for the recruiting, they're going to do all the weighting and all that other stuff. So let's see what they do. Just watching up here the recruiting. There we go. 132 of 132. Workflow failed. I wonder why. Subsetting on file sets 5 of 6. 6 of 6. Weighting on file sets 5 of 6. 6 of 6. It's trucking along. Yeah, I don't know why it failed. It's kind of bothering me. So I am waiting, I am anticipating the result here. Come on. Averaging on file sets 5 of 6, 6 of 6. Reporting geospatial lat max, workflow completed, visualization in progress. There we go, boom. So was the error the fact that I changed the unit from millimeters per hour to millimeters per month? I guess so. Don't ask me why. So there goes my idea of changing the units. Do not change the unit. Let's look at this. All right, so count in, that's your 132 months. That was that period from January 2010 to December of 2020, okay? 11 years. Correlation, plus 0.76. That's a positive correlation. They're directly related. What's directly related? Right here. Sea surface temperature and rainfall at that location in the equatorial Pacific from 2010 to 2020. Okay, it's important. You gotta specify the date and the location, because if the date changes, correlation might change because you might get different values for different other months, and the area changes, you're definitely going to get different values, right? So good. This tells me it is a direct relationship, and they're fairly close to that best fit line there, that red line, right? So yeah, it's a moderate to strong, but not very strong. It's a moderate to strong positive correlation. Okay, so that tells me as rainfall goes up, sea surface, is that sea surface? Sea surface temperature also goes up. As rainfall goes down, sea surface temperature goes down, right? As sea surface temperature goes up, rainfall goes up, so forth, right? So they're directly related. Great. Okay. Now we've determined, let's go back here. We've determined that these time series are directly related, and we've described their direct relationship with the correlation, with the magnitude also. Now let's take a look and actually see, okay, what does the spatial correlation look like? Are there areas within that region that are more correlated than other areas? Okay, so my hypothesis is that this is going to be a pretty boring map, because why? Because it's one small area in the Pacific. I don't think there's much variability there. I wouldn't be surprised if the map is very close to one color, but we're going to check it. Remember, this is just for demonstration. You're going to do a more interesting part of the world and definitely get a more interesting result, I think. So back to data selection, bottom right down here, boom. Okay. Now we're going to do the select plot. We're going to go to, where is it? Where is it? Oh, scatter. Time averaged. No, area averaged. That's what we just did. Where's our, there it is. Stay away from these scatters. We're not doing scatters. What am I talking about? We're doing a map. We're doing a correlation map right here. It's hidden down here in the bottom left. Boom, I'm gonna click that correlation map. Okay, so we're good. That's all we need to change. I'm gonna plot this. It's probably gonna do all that same rigmarole, you know, regridding, subsetting, weighting, all that stuff. Seems to be moving pretty quickly. Oh, much faster. Workflow completed. Love the way that sounds. And here, ladies and gentlemen, is our correlation map. Like I thought, kind of boring. There's no land represented here. Here's the latitude, 0 degrees. Here's the longitude, 135 degrees west, right? So totally boring. Here's your correlation map. And it's all positive. Everywhere here in this region that I selected. I wonder if I can do this. Can I go? Oh, my scroll, I should have done that. Let me go back to the data selection. No, oh, there we go. Let's remind ourselves of the area that I'm looking at here. Pretty boring, right? So yeah, there's not much variability there. So I'm going to go back to results. Let's go back there. Boom. See how easy that is? Okay, it's all directly related there. Look at these strong relationships down here. I'm going to see if I can bump some variation colors here, right? So it's kind of boring. Look, we got all this blue we're not using because the blue is for the inverse relationship, and it's all direct. So let's just, instead of having go to -1, let's have it go to like 0.1. Okay, so we're gonna map only the positive values. We're gonna apply color only the positive values because the whole thing is positive. So right, so we're gonna go to options, correlation options. Here's a range, -1 to 1. Let's have 0.1 to 1, right? And let's change our color palette. I'm going to do a view all palettes. Some of these options I can choose. These are really cool. Sure, let's go with this one. Cyan, red, yellow. You can do whatever you want that makes sense, but I'm sticking with this one. I'm going to add that. Ooh, look, I've got options now. So let's do this. I'm going to just change those data ranges like I did. I'm finding a new color palette and I'm going to replot. And I'm hoping I get some more, a splashier color. Ooh, look at that. Okay, now that's not as good as I was hoping, and I know why, because look, there are no yellows in there. The correlation looks like it's about 0.75 is the maximum. So I'm going to even do this. I'm going to change, I'm going to go back to my option. Instead of my maximum, I'm going to have 0.75. I want a whole array colors in there. Why? Because they're easier to interpret. Again, this is a boring example, but let's see if we can get, okay, look, we're starting. That's a little bit better, but you know, what happens if I go to 0.6? Maybe these correlations are closer to 0.6. And then I'll stop there. You get the point. What's that? Kick a dead horse. What's that expression? I don't quite understand that. Tend to avoid dead horses. I don't see when I want to go kick it. There we go. Look at this. So I'm going to show you something, right? Actually not, because I didn't save the other map. Actually, if I zoom out, look. Oh, I zoomed out too much. Oh, come on. If I zoom out with my scroll and my mouse, look at that. I can tell you exactly where that is. Pretty cool, right? All right. So what I want you to do, I want you to download this map, same way we did with the time series, the same way you're going to do with the scatter plot. Download PNG, I think that means like portable network graphic, something like that. KMZ is a Google Earth file. You could download this as a KMZ, and this is PNG is just your standard, like, you know, your standard graphic you would insert in a document to turn in, right? And here's what it looks like. I saved it. Cool thing is when you save it, the title is provided with all the details on correlation scales. That's great. Now, out of curiosity, what happens if you download the KMZ file? It's a rhetorical question. I know what's going to happen. Let's just show. Okay, so it's downloaded. I clicked it to open it. Double click to open it, and it should open directly in Google Earth, and it looks like it is. And here is your correlation. Navigate. I don't want to navigate there. I'm not a Google Earth navigator. Look at that. There's your correlation map in all of her glory right there. Okay. Look, you got your scale up here on the right too. That is a work of art. I'm gonna give it a little twirl. You twirl it faster. There you go. Oh, well, let's do it. Come on, move that thing. There you go. All right, you get the point. Okay, so to recap, we've looked at 2 time series. We have produced a scatter plot with them and examined the correlation, linear relationship between the 2 variables. We have made a map with the correlation, or sorry, we've made a correlation map between the 2 variables. We've adjusted that map to have a more, I guess, a larger range, color range of values, right? Final thing we're going to do is we're going to look at what's called lagged correlation. Now, before we look at that, let me just explain what we did compared to lagged correlation. We looked at what's called concurrent correlation, right? So how does a January sea surface temperature relate to a January rainfall? How does a February sea surface temperature relate to a February rainfall? Well, or maybe you say, like, how do all the Januaries relate to all the Januaries of the other variable? How do all the Februaries of sea surface temperature relate to all the Februaries of rainfall? That's what we're going to look at next, but we're going to lag it. So we're going to say, like, how does the January rainfall correlate with the February sea surface temperature, right? And they're lagged. It's a 1 month lag in this case, right? So let's open up a window. I'm going to type NOAA PSD map room. It's already done for me. Look at that. Map room PSL, Physical Sciences Lab. I think it's, yeah, Physical Sciences Laboratory. There we go. I'm going to click on that. I believe you're going to go to products, down to analysis and plotting tool. We're going to look for the one down here that says correlation. Come on, I always miss it. It's probably right in front of me. Composites, 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 comparisons, composites, 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 correlations. Right there. Monthly, seasonal correlations, INSEP, NCAR, reanalysis, and other data sets. Boom. All right, so here, rather than doing an area average and looking at some area correlation, we're looking at the whole globe. Okay. Now it's very simple. In this case, I'm gonna pick two random variables. Okay, geopotential height, doesn't matter what it is, some random level, 1,000 millibars. Again, doesn't matter. You're gonna pick something different, and I'm going to correlate it to the Nino 3.4 index. What does that mean? Well, that's the area. Let me show you what that means, right? Let's just do this real quick. Nino 3.4 region. Yes, this is what I want to show you. Okay, see this map right here? This is a good one. Okay. The Nino regions are just regions of the Pacific where the sea surface temperature anomalies are averaged, right? So in the red, or the salmon, whatever color that is, it's the Nino. It's called the Nino 3. And the blue, it's called the Nino 4 region. Over here is the Nino 1 and 2 region. Now, we're going to look at the Nino 3.4 region, which is part of the 4 and part of the 3. It's this black outline. So if we go back to our correlations, yeah, we're going to correlate some random variable here with the Nino 3.4 index, which is used for El Nino monitoring, INSO monitoring, INSO phase monitoring. It's basically sea surface temperature anomalies in that region. All right. So if you just correlated the two, you'd say, okay, what's the correlation look like for January? What's January geopotential height correlated to January Nino 3.4? Just keep those January, keep that all blah 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 blah, nothing, nothing, nothing. Just great plot, right? You know, I don't like this projection for what I'm trying to do, so I'm going to go back, select projection. Nah, we're going to go Northern Hemisphere. Oh, plot region. Sorry, all. We just look at the north. We want all, not just the Northern Hemisphere. We want all for this purpose. Okay. Let's just now create plot. There we go. Look at this. We have the whole world. So what are these colors? Oh, look down here. It's your correlation value. And what's being correlated? Look at the title or the color bar legend. It says that January from 1948 to 2015, 1,000 millibar geopotential height correlation with January Nino 3.4. Okay, look at this. So how do you interpret this? Ooh, purples. Well, that's a negative values. Oh, look. So right around here, there's an inverse relationship between geopotential height at some level and the Nino 3.4 index. Oh, look over here. Here, there's a direct relationship, positive relationship between geopotential height here at 1,000 millibars and the Nino 3.4 index. Okay, whatever. So let's go back. What happens if I change these lags, right? So the geopotential height no longer is January. What happens if it is lag 1? Does that mean that's going to be December geopotential height? or is that leading? Let me get I think sorry. Yeah, if this lags, then this should be February geopotential height. So geopotential height is lagging the January Nino 3.4 by 1 month. Is that right? Great plot, check it out. And I'm wrong. I mixed it up. Look, it's the January geopotential height and the February 3.4. Okay, so this is the correlating variable. And that is right here. This is the correlating variable, right? So if I put 2, this is January, geopotential height, so this would be February, March. This would be the March Nino 3.4. Great plot. There you go. So the January geopotential height correlated to the March Nino 3.4. Why do we care about this? Why do we look at lagged correlations? Well, it is the results can often be a springboard into a more comprehensive research approach, right? So, for example, it's possible to identify a certain what's the word I'm looking for? Early, I don't think early warning, but a variable could potentially forecast, if you want to use that word. It could suggest how a later variable later on might respond, right? So, for example, if there is a strong positive relationship between January rainfall and, January sea surface temperature and March rainfall, well, if January sea surface temperature is really, really high, then that might lead us to investigate if March rainfall will also be really, really high, right? So it allows some sort of anticipation, some kind of outlook. But again, remember, correlation never implies causation. So don't fall in the trap of thinking that if the correlation is a certain value, then it means the other variable responds exactly that way. No, I wanted to emphasize it leads to a springboard for comprehensive research, right? So you're going to get this map, you're going to right click, you're going to save it. I believe you could also get a PostScript version. That's right, you can click that, and this is going to download too. Boom, boom, boom. Allow, I'm allowing something here. What happens if I open that? I get the spinning wheel of death. Okay, I'm not going to mess with that. Maybe I will. Probably should I click on that? Oh, come on. No love from the spinning wheel of death right now. Okay, I'm going to pretend I didn't do that. And one interesting bit of information here is that the global maximum correlation and the minimum. So the largest correlation here, or the largest positive correlation here is 0.8, probably like right there. And the largest negative correlation is negative 0.65. That's probably something like right there. All right, so I'm going to go back. I don't want you to plot random variables. No, I want you to plot precipitation rate and the Nino 3.4. Okay, and I want you to look at the February, right? And I also want you to look at, actually, I take it back. let's go to December. Where are you, December? There you go. Let's go December rainfall rate. 10, this is a 0. So I'm going to do like a concurrent correlation between these two. And then I'm going to ask you to do lagged correlation by 2 months. So December and February correlations, right? All right, so here's basically the assignment or the exercise or the project for this week. What we're going to do, when I say we, I mean you, you are going to produce a pair of time series maps like we did with Giovanni. Show the area average location. Show me that box with the area average. Let me see where this area average was. You're going to produce a scatter plot like we did before. You're going to produce this correlation map like we showed before, correlation map with adjusted color scale, and a lagged correlation map between your precipitation and Nino 3.4. Now, I also want you to interpret these, right? So I'm going to, in addition to this video, post the questions. But hopefully this video has summed up everything. It'll show you how to use NASA Giovanni, data selection, NASA Giovanni, and also the NOAA web portal to explore correlations, right? And so with that, I think we're going to end it. And as always, send me questions in email or WhatsApp if you have them. All right. So I'm going to end this.